Hi friends, there is one more problem with the moment of inertia. In the previous classes, I was explaining about the moment of inertia of different sections like triangle, rectangle, right? In today's class, I'm going to explain you about moment of inertia of a section with respect to its weight. Now here we have a question, right? We have to determine the moment of inertia of this particular section with respect to its base. So I'm just drawing a line over here, an axis, which is simply representing the base of the section. So I can take this one as capital X and X. Now the dimensions of the section or the height of the section is given as 40 millimeter. The total width of the section is 30 plus 40 plus 30, again it is totally 100 millimeters. Now as soon as you see any section, right, the only thing which should strike in your mind is you have to divide this entire thing into number of sections. So I have divided this thing into four different sections, right? As you can see here, I have simply drawn two lines. Now these two lines, right, they are dividing this entire section into a triangle, a square, another triangle, from which a semicircle is being removed. Now I'll just draw them individually and I'll show it to you. Now here you can see there are the first triangle, next the middle one, the square, next a triangle. Now there is a missing part, a semicircle. Now this semicircle is removed from the square. Now I have simply drawn it over here, a semicircle. The dimensions of the triangle are 30 millimeter. The base of the triangle is 30 millimeter. The height of the triangle is 40. And the square, it is 40 by 40 again. Semicircle, it has got a diameter of 40. Now to calculate the moment of inertia with respect to base, earlier we have determined some formula for the triangle, the rectangle or a square, as well as the semicircle. Obviously the moment of inertia of a semicircle will be half of the moment of inertia of a circle. Now first one, the formula: moment of inertia of a triangle with respect to its base will always be equal to bh cube divided by 12. Next one, moment of inertia of a rectangle with respect to its base, as we know it, it is equal to bd cube divided by 3, where b is the width and d is the height of the, either it may be a square or a rectangle. And the last one, moment of inertia of a semicircle. Moment of inertia of a semicircle, it is half of moment of inertia of a circle, that is half of pi d power 4 divided by 64. Now pi d power 4 divided by 64 is the moment of inertia of circle. For my convenience and to solve the problem easily in the examination, what I have done is I have drawn a table with serial number, section, dimensions of the section, and moment of inertia with respect to the base. The first section which I am considering here is the triangle. Either it may be the right or left triangle, whatever the triangle. The base of the triangle is given as 30 millimeter and the height of the triangle is 40 millimeter. We know that moment of inertia of the triangle is bh cube divided by 12, right? We have b which is 30, h which is 40, cube divided by 12, that will become 160000 millimeter to the power 4. The units of moment of inertia are millimeter to the power 4. Why millimeter to the power 4? We have width b, the dimension of this one is millimeter, height h, millimeter cube. So totally it will be millimeter to the power 4. Okay, the next one is rectangle or a square, the middle portion, whatever the middle portion we have taken earlier, right? Now this middle portion I am considering here. The width of the section is 40 millimeter, depth of the section is again 40 millimeter, or you can take that one as side S, which is equal to 40. Now moment of inertia with respect to base, it is equal to bd cube divided by 3. Now so obviously this will become 85333 millimeter to the power 4. Now the last one, it is a semicircle. The diameter of the semicircle is given as 40 millimeter, and the moment of inertia of semicircle is half of moment of inertia of the circle, half of moment of inertia of the circle. So it will be half of pi d power 4 by 64. Diameter is given to us as 40 millimeter, so it will be half of pi into 40 to the power 4 divided by 64. The value of this one will be 62831.85 millimeter to the power 4. Now as we know that when you see this particular section, right, it has got a triangle one more triangle, the middle one, a square from which semicircle is removed. From which semicircle is removed. So the formula will become moment of inertia of the section, which is equal to moment of inertia of the triangle plus moment of inertia of the square or rectangle plus moment of inertia of the triangle, the other triangle, this side one, and from which we are removing moment of inertia of the semicircle minus semicircle. So this one multiplied by 2, as we have two triangles, plus this one minus semicircle. So it will be 2 times 160000 plus moment of inertia of the square or rectangle minus moment of inertia of the semicircle. So moment of inertia of this particular section will be 3110501.45 millimeter to the power 4. So you have to practice this problem. So it is very important and it is repeated nearly 4 to 5 times in the examination. Thank you.